You have held this 1,000 times. You have never once looked at it closely. This piece of paper is not paper. 30 billion banknotes printed every year just for the euro. Add every other currency on Earth and the number exceeds 150 billion.
This building prints currency for an entire nation. It has no windows facing the production floor. It is patrolled around the clock.
Every employee entering this facility passes through 4 separate security checks. Phones are surrendered at the gate, no exceptions, no employee-level banknote paper is not regular paper. It is 100% cotton fiber, no wood pulp, giving it a distinctive texture and a lifespan of years in circulation. The watermark is not printed. It is formed during the paper-making process itself, when the wet fiber pulp is pressed against a textured roller that displaces fiber density. The security thread running through every banknote is embedded inside the paper, not printed on top of it. It is a polymer strip proprietary. Offset printing applies there's the background pattern, the intricate, repeating geometric lines called guilloche patterns. A commercial printer's maximum practical line resolution is approximately 0.3 millimeters before lines begin to merge or break up. Intaglio printing is unique to banknote and high-security document production. It uses engraved steel plates. Engraving one intaglio plate by a master engraver takes between 3 and 6 months.
This engraver is working on the master plate for the next generation of banknotes, design work that takes 3 years from initial concept to final approved plate.
The wiping stage is critical. Excess ink must be removed from the plate surface, while leaving ink only within the engraved grooves. Every banknote includes tactile features specifically designed for blind and visually impaired users. Raised dot or line patterns near the edge that indicate denomination. Optically variable ink contains microscopic multi-layer flakes, each one a stack of materials only nanometers thick, engineered to reflect different wavelengths of light depending on the viewing angle. This color shift cannot be photocopied, scanned, or digitally printed because it depends on a physical optical structure, not a pigment color. The holographic foil strip is itself manufactured by a separate, highly specialized process involving laser-etched master images. The diffraction structures in this foil are spaced at intervals of less than 1 micrometer, 1/1000th of a millimeter. Every banknote carries a unique serial number. The numbering press tracks an increment automatically, synchronized precisely with sheet position. A numbering error, a skipped digit, a repeated number, a misaligned print, triggers an automatic rejection of that specific note from the production line. Each printed sheet contains up to 60 individual notes arranged in a grid. The final cutting stage separates them into single notes. Maintaining sequential order through the cutting process is as critical as the cut itself. A stack of notes that becomes disordered cannot be reconciled against the printing records. The automated inspection system examines every single banknote individually, not a sample, every one, comparing it against the master reference image. The inspection system processes each note in a fraction of a second, checking dozens of distinct quality parameters simultaneously. Every rejected note is destroyed under the same security protocol as a genuine completed note. The shredding and briquetting process. Notes are packaged into bundles of a standardized count, each bundle sealed with tamper-evident wrapping and a unique identifier. The tamper-evident seal on a banknote bundle is designed to fail visibly and irreversibly if opened. There is no way finished currency does not leave the production floor directly. It is held in a secure vault, awaiting scheduled transport to the central bank's distribution network. Currency leaving this facility travels by armored convoy under armed escort. The route is never publicized and is varied between shipments specifically to prevent pattern recognition. Every bundle is logged into a national tracking system the moment it arrives at the distribution center. From this point forward, every banknote's movement through the formal banking system.
Every time you deposit cash at a bank, it passes through a machine that verifies the same security features described in this video: the watermark, the security thread.
Many banknote security features are specifically designed to be invisible under normal lighting and only detectable under specific conditions, such as ultraviolet or infrared light.
When a suspected counterfeit note is identified anywhere in the banking system, it is sent to a specialized forensic laboratory for detailed analysis.
Side by side under magnification, the difference is unmistakable to a trained examiner. The genuine note's intaglio printing shows clear raised relief. The counterfeit is completely flat. Banknote security is not static. Every major currency redesign, occurring roughly every 7 to 10 years for most national currency. A security feature that fails after months of normal circulation handling is not viable, regardless of how secure it is when new. Polymer banknotes, pioneered at scale by Australia in 1988 and now used by over 50 countries, use a transparent plastic substrate. The clear window is not a hole cut into the note. The polymer substrate itself is transparent in that region, with the surrounding areas printed using a special ink. While this video focuses on banknotes, coin production operates under parallel security and quality control principles. Coin blanks are struck under pressures exceeding 60 tons. A low-denomination note changes hands frequently and wears out faster, typically lasting 1 to 2 years in active circulation. Approximately 150,000 notes are removed from circulation and destroyed every single day in a mid-sized national economy, simply due to ordinary wear. Central banks around the world, despite intense secrecy regarding their own specific production methods, collaborate closely on counterfeiting trends and emerging threats.
Over 130 countries are currently researching or piloting central bank digital currency. If widely adopted, it could...
You started this video looking at a building that revealed nothing. You now know what happens inside it. The engraving that takes 6 months, 30 billion times a year, for one currency alone. The most secured, most inspected, most engineered piece of paper most people will ever hold. It is not paper. It never was.
Choosing what appears on a banknote is a political and cultural decision, but every visual choice must also survive a security feasibility.
By the time a banknote design is approved for production, it exists as 2 complete documents. One is the artistic design, the portrait, the colors, the imagery. Banknote ink is manufactured by a small number of highly specialized companies, operating under strict government licensing in multiple...
If a counterfeit note somehow contains ink that matches a legitimate taggant signature, that signature alone tells investigators...
The greatest security risk to any currency printing facility is not external attack. It is internal diversion. An employee attempt...
Every employee is searched leaving the facility with the same rigor as entering it. This applies to the facility director as much as the newest production line worker. Banknote security from 100 years ago relied primarily on the skill of the engraver and the difficulty of accessing a printing press.
This note, issued generations ago, was considered virtually uncounterfeitable in its time. Today, a determined
The security printing techniques developed for banknotes have migrated into passport production, academic diploma certification.
Counterfeit pharmaceuticals kill an estimated several 100,000 people annually worldwide, primarily in regions with weaker regulatory enforcement. Intaglio printing did not originate with currency. It originated in 15th century fine art printmaking, used by artists to...
An artist using intaglio technique to produce 50 signed and numbered prints, and a national mint using the same fundamental technique to produce 30 billion banknotes.
Successful large-scale counterfeiting operations are rare, specifically because the security technology described throughout this video has made amateur...
A banknote with a face value of 50 euros costs a small fraction of that amount to produce.
A banknote printing works cannot a power outage mid-production run without risking spoiled batches and security accountability complications.
Cotton paper absorbs and releases moisture constantly, expanding and contracting by fractions of a millimeter as humidity changes.
The public unveiling of a new banknote design represents the only moment the years of secretive development work becomes visible.
This is where it ends. Not in the vault, not in the armored convoy. Here, in someone's hand, in an ordinary bank branch, on an ordinary day. 30 billion times a year. 6 months to engrave. Gold-priced ink. A thread you cannot see embedded in fiber you can... It is still just paper to you. That was always the point. Cotton fiber and wood pulp fiber look similar to the naked eye but behave completely differently under polarized light microscopy. Wood pulp fibers contain lignin.
This single test, performed in seconds with equipment that costs a few $1,000s, eliminates the vast majority of attempted counterfeits.
Banknote paper does not use the same cotton as clothing. It uses cotton linter, a short fiber byproduct of...
The degree to which cotton fiber is beaten during pulping directly determines how well the wet pulp will respond to the watermark-forming dandy roll later in the process.
Dandy roll is itself a precision-manufactured object, its surface pattern engraved to create the exact watermark image approved for the current currency design. At this exact moment, in this exact location, on this exact machine, the watermark is created. It will never be created again, and drying must occur gradually and evenly. Rapid or uneven drying causes the paper to warp or develop internal stress that affects how it behaves later. Substrate rejected at this stage never reaches the printing works at all. It is far more efficient to identify a flawed watermark or misplaced thread before months of subsequent engraving, printing. Blank banknote substrate, despite carrying no printed value whatsoever, is transported with security comparable to finished currency. The machines capable of true intaglio banknote printing are themselves controlled items under international export regulations.
Ordnance. Before this press can be shipped, the manufacturer must verify, and the exporting government must approve, that the buyer is a legitimate.
An apprentice engraver spends their first 2 years practicing on non-currency patterns, developing the fine motor control and tool feel requirements. This comparison is shown to every new apprentice on their first day, specifically to illustrate the gap they must close. Few members of the public ever see this complete chain laid out, because almost none of the actual production process is ever shown.
These children will spend money for the rest of their lives without ever again looking at it this closely. This museum visit may be the only moment.
Every vending machine, parking meter, and cash-accepting ATM contains a miniature version of the same security verification technology used by central banks and commercial cash processing centers. The fundamental physics does not change between a forensic laboratory and a vending machine. Magnetic ink either responds to a magnetic field or it does not.
This trade show represents one of the few settings where security printing professionals from competing companies and competing nations openly discuss innovation.
Instances. What you are looking at here may appear on a banknote somewhere in the world in 5 to 8 years after the lengthy security validation.
Despite everything described in this video, the months of engraving, the gold-priced ink, the electron beam lithography, the central bank's primary public guide.
5 seconds. That is all the verification this entire production chain requires from the person actually using the currency.
The counterfeit detection pen found in millions of retail registers worldwide exploits the exact same cotton versus wood pulp fiber difference described earlier in the forensic laboratory. Every single process shown throughout this video is happening simultaneously, right now, in this building and in similarly secured buildings around the world. At 3 in the morning, this building is still running. The night shift inspects notes with the same rigor as the day shift. 6 months of engraving, gold-priced ink, a thread embedded in wet fiber before it was even paper, a hologram built from structures smaller than light itself. It is still just paper to you. That was always, exactly, the point. Pilpins. Before any new substrate formulation is approved, it endures a simulated lifetime of abuse in a matter of hours. Before any production run is officially closed and released for distribution, every document generated throughout the entire process is cross-checked against every other document. She will spend her career looking at this piece of paper more closely than almost anyone else alive, checking the fiber, checking the ink, checking the relief.
35 years. Every note that left this building during that time passed, in some sense, through their accountability.
Currency security decisions are sometimes made years ahead of schedule, not because of any confirmed breach, but because of credible intelligence.
Every central bank receives a predictable number of public requests every year from people who have washed banknotes by accident. The substrate is specifically engineered to survive this exact scenario. There is no moment, day or night, when this building is unattended. There is no moment when currency exists inside it without someone accountable for its presence.